The next paper is paper ID 191937, Design and Develop Sign Language to English Script Converter using AI and Machine Learning. The author is Mr. Bhausaheb Khamat.
Yeah. The research is about the analyzing and converting sign language to English language using AI and machine learning. Let me go to so I have the content of the slide is like introduction, objective, literature survey, problem statement, and the methodology that we were using, and the results that we are expected from this one, and some of the references. So introduction. So as we know that there are like a lot of papers and solutions regarding the sign language, but in this paper we'll see how we are different from there. So let's talk about the sign language first. So the people who are not able to talk or not able to express their the communication, so they were using this language as a communication medium to us, so they face a lot of difficulties to talk to normal people like us, because we are not able to understand them. So uh, it's actually a need for us to have a medium to take their input and understand what they're talking. And again, like if they're not able to hear as well, so we should have something the system should like generate whatever we are saying to the text, or some format that they were understanding. So this is the introduction of that. And so in this one, we have basically used the existing CNN models to detect the gestures, and also in extra we have used the machine learning for the trend data sets. So let us go to the objective. So as I told, uh, so we in this one, we have reviewed a lot of papers. So in that one, uh, the limitations that we are minimizing, like capturing, is that it will take a lot of time to process even the single word. So our objective is to minimize that time, and have a system which will give like output like a real time, instead of taking a lot of time. So that is one. And also while capturing the data, so just like our auto type, so the system should analyze what the sequence of different like gestures will be next. So let's say if someone is saying what is your, so next will be they should give a suggestion like what is your name or what is your birthplace, kind of that system. So it will minimize the time or efforts from their end. So also, we have a lot of signs or with the different languages. So this is an extensive like feature. Like uh, what we do in the system is like we upload the signs or gestures, and we are expecting the results when that gesture is appearing, or got there. So what it does is it is work on the basis of what they have, what the system has actually, so not on the real time. So uh, so as we are working on the machine learning algorithm, so let's say if there are 10 different combinations for hello. So if someone is like using the 11th one, and we tell system that this is the combination for hello. So next time uh, the system should be tell us the result about the it should analyze that this is the hello word, and this is coming from the user, not from the one who is creating the system. So it is basically a model where user can upload their signs and sign and gesture, and they will use uh, accordingly, not on the system basis. So just like a software, like a system that suppose the user, not the administrator. And So all this uploaded science will be processed through like model and added to the data sets that we have. So next time it will capture and it will give the result. So literature survey. So basically, I have gone through a lot of literature survey I added in the paper, but for the presentation, I just segregated five men of them. So let us go with the first one, Arabic Sign Language Recognition System using 2D hands and body skeleton data. So this is in 2021, and for there they have used the special camera to take the data, and that data will camera will take the hotspot of the gestures, and then it will pass to the system. But from the general camera, it is not they cannot process this one. So they might have later they might come with a compact version of the camera, but still we need to purchase the camera for that one. So that was one of the limitations that they have. The next one that I have referred is like research of sign language translation system based on deep learning, done in 2019. So this is the paper that they have researched on the uh, existing data that they have, but they haven't worked on the data sets and the AI. So they have uploaded only the A to Z characters from the gestures, and not more on the words data sets. uh, yeah, that was the limitation for that one. So next paper is an efficient sign language translator device using CNN and customized ROI segmentation. So done in 2019, as the problem statement says, they needed a specialized device as the first one. They have a different device to identify the gestures, and also they didn't work on the data sets as well. So that was the limitation that they have. And implementing gesture recognition in sign language learning application. So uh, here they have worked on the characters specifically, let's say A B C D kind of that word, but not on the word. Let's say hello, hi, hello, what is your name, so kind of that. So for every gesture they need to capture HELLO, so kind of that. So every character they need to work on that one. So that's the limitation. So instead of words, they use gone through the characters, so which is the time consuming and in the application. So the last one I have the backend view based continuous sign letter recognition using a rewound video sequence and the previous sign letter information. So this one was the good one. Even they have worked on the what we have the previous letters, and this is I also use what was the previous letters and what could be the next letter, so to guess that one. But at the end they needed a lips motion sensor to work on this one. So every device will not have that one. So that was the limitations for that one. The next one, our problem statement is analyzing and converting sign language to English language using AI and machine learning. So let us go. So methodology that we have used. So uh, most of them are similar, but we have two main. One is the machine learning, predictive modeling on frequent data sets, and AI recipes that we have used. And let us go with the first data set generation. So this is the main instead of storing some gestures, we should have data set generation. So let's say we every sign is different for every people, like just like this handwriting is different for every person. So kind of that. So data set, let's there are 10 different combinations for hello, so that should be not only 10. So if there are 1,000 people, so there will be a lot of combinations for that word, so that should be stored uh, in in the data set. So next time if someone came uh, with the hello with any of the sequence, so they should able to retrieve that one. And gesture classification, so once we got the gesture, so like there should be a some minimized sequence of the gesture, so what that word could be, so that it will be done in the gesture classification. And our traditional CNN model we have used to crop out the things and what the actual word is. So that is also in every model we saw this one where they have used CNN model. So this also we have used. And the machine learning on predictive modeling on frequent data sets. So as we are working on the data sets dynamically generation and storing that one, so we have used their predictive modeling as well. And last is bag of feature model, clusters of feature using k-means clustering. So this is also used for the generation of the sign, extracting the features from the images or the frames that we have. So user journey, like this is for the user perspective. So once they have, so we basically aim to have the mobile device this software will be available for the mobile device, and they will just interact with us and with the hand movements of there, so that movements will be captured in the frames, and uh, they will be processed through the machine learning algorithm. So not always available on the internet, but that model should be available on offline as well in the mobile. So whatever the data sets while when they are online, so they have took that one in they have stored that one in the mobile devices, and from that one they will analyze the captured sequences from the frame, and then our the k-means and the bag of features and also the CNN model that will be work after the processing from the ML, then they will process that one and will give us the input at the end of the journey. And this is the high level design that we have. First is the sign hand movements that we'll be getting. We will validate the input, and there are this all are the CNN layers that we have to get the data. And lastly, we got the optimized format of the gestures, and from that gesture we'll get the extract feature, like what that sign or gesture will be, and that gesture will be stored in the ML as a data set here, and then we will process that one. Once that is processed, will give the result, and that result and processed format is also stored in the
Kamat,
data
you are
sets.
having last 1 minute to finish up
Oh,
because we are within a time.
yeah, yeah, just 2 minutes, 2 minutes. Yeah. And this is the CNN traditional model that we have. We have the raw image, let's say, and that from that raw image we'll have a skin masking. Then again we have the edge detection. Then we have the the hotspot of the that one, and we'll take a feature from feature clustering from that one, and then feature classification. So this one will be as an input to the ML that we will be giving, and the expected result is like we should have that application working on the mobile, and also we should give text format at the end of the result, and also the audio format if it is if they are able to hear. Then and also we should also user should be also contribute to the new science that they have, and some of the references that I will use. Yeah, that's about me. Thank you. For questions.
Shiv Kumar sir, over to you.
Fine. Actually, may I know how many papers you have studied? I mean, literature
Uh,
review.
Near about 18 to 20.
But you have mentioned very less, right? In this
Yeah,
PPT.
for the presentation, I just segregated like the main one.
Fine. The good thing is you have studied very recent paper. It is very good actually.
Yeah.
And in each and every paper, you have mentioned some limitation also, right?
Yes, yes.
So is your system overcome all the limitations?
Mostly all, because like the current system that we have, this basically on the devices or the AI model. So they will not they are not working on these things. So they like we have the softwares or applications also, but they are not working on the data sets as well. So yes, I can say like they currently uh, it is overcoming all limitations.
Can you list out some limitations that you have overcome?
So the paper mostly that I have referred, they have used the lip motion sensors and to gather the extracted gestures. So that
One
we
minute.
Mhm.
So lift movement also you have to identify, right?
Yes, yes.
See,
No,
right
no, no,
now.
no. Uh, Only this is only for the hand gesture thing.
So you said lip motion like that. That's why I'm asking this question.
No, no, that leap motion sensor is for the camera devices. Like uh, it is not on the lip, but it is like the naming is that, but it is not on working on the lips actually.
Yes, because I mean, due to COVID situation, many of them are using. Many of them, many of us are using mask, right? So it is difficult to
Yeah,
identify.
that leap motion sensor is like basically after each interval that it will form the frames. So that is why it is called leap motion sensor.
Fine, fine. Okay, so here the data set. What kind of data set you are using, man?
Data sets actually it's actually for the machine learning. So not only we have like for the one word there are a lot of combinations. So uh, for that combinations we are storing each and every combination, and also the user can upload their combinations not only from our side. So it's basically user will derive the systems later on.
See, I'm asking whether you are generating the data set or already existing.
We are not like we uploaded our own data sets, but it is ultimately the user who will upload more datas in the system.
Okay, how do you classify that gesture?
uh, yeah, for the classification we use the traditional methods. So whatever the existing methods they have used in their research. So we have used the CNN models, we have used the bag of clustering, so for identifying the features. So that we have used.
So these are all the algorithms already used.
Yes.
In what way yours is special?
uh, they haven't the one is I said like let's say they have used 10 different combinations for one word, but what will if there are the last one some 11th one has appeared. So system we need to again modify our data sets and put that one. So but here user can contribute their things, and it will be stored in the data set uh,
Okay,
for the next year.
fine, fine. Your effort is good, and you have to improve more also, right? Fine.
Okay, yeah, yeah, yes.
Thank you.